Okay, here we have more of the transformations practice quiz. We've done problem number 1. Problem number 2 is down here. Rotate 270 degrees accurately. So, and we want the CC just means counterclockwise. So I'm going to take my tracing paper here, and I'm just going to draw my axis. It's important to draw the axis and the points just every time. I'm going to draw my axis. As well as I can, and then point, point, point. Clock is going this way, so counterclockwise goes this way. This would be a 90-degree rotation. This would be 180-degree rotation. The next 90 degrees would be 270 degrees. So I'm right over here. And these are my 3 points. I'm just going to plot these down here. This one looks like it's like 3, -2. Looks like there. The next one looks to me like about 8, negative, whatever that is, -6. Looks like right about there. And yep, that seems right. And then third point is 4, -7. Let's make sure that looks pretty good. Let's check that and make sure it looks right. Good. Now here's the thing. If you look at the first point, this point here was the point 2, 3. So I know when it twists, it's going to have 2s and 3s. The question is it going to be this point 3, 2, or is it maybe over here 2, -3 over here, right? And the only real way to tell is by using this tracing paper. And it should line up. Now, the other thing you could do is 270 degrees counterclockwise is the same thing as going 90 degrees clockwise. I could do that, and it would be the exact same thing. Okay? On the back, fully describe this transformation. Okay, so I got to see what's going on here. I'm going to go ahead. Here's my axis. I'm going to go ahead and put, oh, this is the original one. The ABC is the original one. The one with those little marks is the transformed one. So when it says A, and then this is A prime is what we would say. That means this is where A has been moved to. So this is the new one. This is the original one. Okay, so we've got this triangle here. And let's see, what would we do to make that match up? Would a rotation work? No, a rotation does not work. So it's not a 180-degree rotation. What about a reflection? What if I flipped it over the y-axis first and then over the x-axis? Nope, that doesn't work either. Okay, what are my other options here? I could try, what about the line y equals x? Remember, that's the line that goes right here, straight down the middle. I'm going to put that on my paper too. That's the line y equals x. Starts at 0, has a slope of 1. I'm going to take this and I'm just going to flip it diagonally right over there. I'm going to line up that line and, hey, look at my triangle. There we go. That's the thing. So what do we do? This is a reflection over y equals x. Now, if we were asked to see, okay, what is happening to my x's and y's? Well, this point B was -5, 1, and now it's 1, -5. So what happened to x? Well, at -5, and now has to go second, but it's going to be the exact same sign. So it'll go second. The x value is going to go second. The y value was second, was 1, and now it's going to go first. So it's just reflecting, it's going to change the order of x and y. Okay, we've got this diagonal, we've got this rectangle, and it says which transformation will not carry the rectangle onto itself. So I'm going to go ahead and draw this one here. Here's my original rectangle. So I'm trying to see what thing, It says a reflection over the line y equals x. Well, let's see where that is. That's right here. The line y equals x goes just like that. I'll draw that line in here and see if I reflect it over that line, do I get the exact same thing? Does it reflect it onto itself? Let's see. Flip over that line, and I got the same thing. So reflection along the line y equals x does carry it onto itself. What about the reflection over the line negative x plus 10? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And negative x means a slope of negative 1. So what if I reflect it around this line? What's going to happen? So I'll set this up here, and I'll reflect this line. Let's see what happens. If I flip it, so this is my axis, I'm just going to flip right around there, line up the line, and look, I get the same rectangle. So this does map it onto itself. A rotation of 180 degrees around the point, 6, 6. Let's find that. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, there's my point. Let's get my tracing paper back here. My point was right here. So if I go 180 degrees around that point, it's like that's where it's starting. I'm going to spin around there. So I'm going to go, see, that'd be 90 and 180. Ah, that is not the same. That is not the same. I think that's the problem here. Let's try the point 5, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. What if that one was my center that I was rotating it around? If I put that in the middle and I rotate it, there we go, 90. There's my 180. Aha, that one works. It puts it right onto itself. So that's all fine. Last question is what is the equation for the line of reflection that maps the trapezoid onto itself? So if I take this thing, what would I need to do to it so that I could reflect it and it would end up being the same onto itself? So I'm going to draw my trapezoid here. So I'm thinking a line like here, right down the middle, that if I flipped it around that line, oh, I better draw it on here too, but if I flipped it around that line, yeah, it would end up being the same. So where is that line? That is right there at -2. So this line at -2, and the way I would write that is that's at x equals -2, because it's going this way. These are my horizontal values. Right? If I take this trapezoid around that line and I make that the center, it reverses and it's right on top of itself. So here's my option, x equals -2.